Colorectal cancer is the third most common cause of cancer death in the world. Thankfully, the good bacteria in our gut take the fiber we eat and make short-chain fatty acids like butyrate that protect us from cancer. We take care of them, they take care of us. If you do nothing to colon cancer cells, they grow. That's what cancer does. But if you expose colon cancer cells to the concentration of butyrate our good bacteria make in our gut when we eat fiber, the growth is stopped in its tracks. But if the butyrate stops, if we just eat healthy for one day and then turn off the fiber, the cancer can resume its growth. So ideally, we have to eat lots of fiber-rich foods, meaning whole plant foods, every single day. But what about the populations, like in modern sub-Saharan Africa, where they don't eat a lot of fiber, yet still rarely get colon cancer? They used to eat a lot of fiber, but now their diet is centered around highly refined cornmeal, so low fiber yet still low colon cancer rates. This was explained by the fact that while they may be lacking protective factors like fiber, they're also lacking cancer-promoting factors like animal protein and fat. But are they really lacking protective factors? If you measure the pH of their stools, the black populations in South Africa have more acidic stools. Lower pH means more acidic, despite comparable fiber intakes. As we learned before, that's a good thing. We want alkaline pee, acidic poo. And that may account for the lower cancer rates. But wait a second, low colon pH is caused by short-chain fatty acids, which are produced by our good bacteria when they eat fiber. And they weren't eating any more fiber, suggesting there's something else in addition to fiber in their diets that was feeding their flora. And indeed, despite low fiber intake, the bacteria in their colon were still churning out short-chain fatty acids like crazy. But if their bacteria wasn't eating fiber, what were they eating? Resistant starch. The method of cooking and eating the cornmeal as a porridge resulted in an increase in something called resistant starch, which acts in the same way as fiber in the colon, as a prebiotic, a food for our good bacteria to produce those same cancer-preventing short-chain fatty acids. Resistant starch is any starch that resists digestion, is not digested and absorbed in the upper digestive tract, or small intestine, and so passes down into the large bowel, or colon, to feed our good bacteria. See, when you boil starches and then let them cool, some of the starch can recrystallize into a form resistant to our digestive enzymes. So we can get resistant starch eating cooled starches, pasta salad, potato salad, or cold cornmeal porridge. So this may help explain the striking differences in colon cancer rates. Thus, they were feeding their good bacteria after all, but just with lots of starch rather than fiber. Consequently, a high-carbohydrate diet may act in the same way as a high-fiber diet. Because a small fraction of the carbs make it down into our colon, the more carbs we eat, the more butyrate our gut bacteria can produce. And indeed, countries that eat the most starch have some of the lowest colon cancer rates. So fiber may not be the only protective factor. Now, only about 5% of starch may reach the colon, compared to 100% of the fiber. But we eat up to 10 times more starch than fiber, so it can potentially play a significant role feeding our flora. So we're talking about even non-resistant starch. So the protection Africans enjoy from cancer may be twofold: a diet high in resistant starch and low in animal products. Just eating more resistant starch isn't enough. See, meat contains or contributes to the production of presumed carcinogens such as N-nitroso compounds. If you split people up into 3 groups, and you put one group on a low-meat diet, second group on a high-meat diet, which includes beef, pork, poultry, and the last group on the same high-meat diet but with lots of resistant starch added, the high-meat groups had 3 times more of these presumptive carcinogens and twice the ammonia in their stool than the low-meat group, and the addition of the resistant starch did not seem to help. This confirms that exposure to these toxic compounds is increased with meat intake, and 90% was created in our bowel. So it doesn't matter if we get nitrite-free, uncured fresh meat. These nitrosamines are created from the meat as it sits in our colon. This may help explain the higher incidence of bowel cancer in meat-eating populations, along with the increase in ammonia, neither of which could be helped by just adding resistant starch on top of the meat. So the deleterious effects of animal products on colonic metabolism override the potentially beneficial effects of other protective nutrients. So we should do a combination of both more whole plant foods and less meat, along with exercise, not only for our colon, but also for general health.